All right, so let's go over 1C evaluating expressions. So let's see. Mackenzie, do you know what evaluate means?
Doesn't it mean to like simplify?
In a sense. Do you think you could be more clear on what evaluate means? Because like we have evaluate and we have simplify, and I'm trying to figure out what's the difference. Because evaluate does mean simplify in a sense.
To like break down problems.
Okay. Yeah. So the difference between the two is this. Simplify means to kind of like reduce and to kind of make an equation more condensed or like simpler, you know, by combining like terms or by like reducing a fraction. That would be simplifying. But evaluate, it's a different type of simplification. But what you do in evaluating is you're going to be plugging in numbers and then you're going to be kind of reducing it from there. Does that make sense to you, Mackenzie?
Yeah.
Okay. So variables, let's pick on Kanye. Kanye, can you give me an example of a variable? Nice. What about you, Jack? Can you give me an example of a variable?
X.
X, very good. X is a variable. Any other variables? Anything else? Let's go with Liam. Liam, can you give me an example of a variable?
One.
Y. There you go. All right, so a variable is a letter that represents a number. That's all a variable is, okay? And it doesn't have to be a letter. It could be a symbol. It could be like, I don't know, a triangle, or it could be like a tree. It's whatever you want. Now, what would a constant be? Does anybody know what a constant is? Nate, do you know what a constant is?
Isn't it just any number?
Yeah, it's a number. So a constant is a number. It doesn't change, hence the name constant. So, Sophia, could you give me an example of a constant?
2.
2. And Neve, can you give me an example of a constant?
5? No, sorry.
No,
It's 5.
2 and 5 are examples of constants. They're perfect. Now, what is an algebraic expression? Well, in order to discuss an expression, the other part of that is an equation. So what makes something an equation? There's one thing that makes something an equation, and if you know what that is, then if you take that away, you get an expression. So, AJ, you there, buddy?
Yeah. Yeah.
It's all good. AJ, what makes an equation? What does an equation have to have? And if you kind of think about the word equation, you're going to hear like something that sounds like another word that will lead you to the right answer. So think of equation. What is it?
It has to have an answer.
It does.
Like,
But
it
like,
has to solve something.
yeah, what is right before the answer in an equation? There's kind of like a symbol. Do you know what I'm talking about?
Equal sign.
Equal sign. So an equation has an equal sign. So what do you think an expression is? What is an expression? It's missing a what?
Hmm.
What's not there in an expression? You just said it.
Equal sign.
Yeah. So an algebraic expression doesn't have an equal sign. Okay? So basically, this is an expression. Notice no equal sign. 2x plus 5. Y minus 2. Both of these are expressions because there's no equal sign. So the difference between an expression and an equation is simply one has an equal sign and one doesn't. And at the start of the lesson, Mackenzie says, well, evaluate means to make it simpler. So in these, evaluate is going to mean replace the variable with the number. All right? So to evaluate an algebraic expression, substitute a number for each variable. So I'm going to underline substitute a number for each variable. Now here it says x is 3 and y is negative 2. I'm going to do that. Okay? So when I'm evaluating this expression, what I'm going to do is I'm going to simply replace the x with 3. Is everybody okay with where I got 5 times 3 plus 7 from? I'll take that as a yes. And now I just simplify this. So, Alice, what is 5 times 3 plus 7? What was it? 22, perfect. So my answer is 22. Over here, okay, I have 14 minus, now I have x. X was 3, so I'm going to have 3 squared. Harshan, what is 14 minus 3 squared?
5.
Perfect. Now, in number 3, I have 2 variables, x and y. So I have 3 times 3 minus 4 times negative 2. Drew, what's 3 times 3 minus 4 times negative 2?
17.
17. Very good. Because 3 times 3 is 9, negative 4 times negative 2 is 8, 9 and 8 is 17. And then this guy says negative 5 times 3 plus 2 times negative 2. What would that be, Sophia Phillips?
So I got negative 15 for negative 5 times 3.
Mm-hmm.
And then for 2 times negative 2, I got negative 4. And then negative 15 plus negative 4. I don't know which like way I'm supposed to go. Like if I add the negative, like I don't know.
Okay, let me rephrase it for you. If you owe me $15 and you owe me $4, how much do you owe me? If you owe me 15 and you owe me 4, does that help you, Sophia?
I can't hear you.
No, you can't. How about now? If you owe me,
Okay.
if you
Yeah.
owe me 15 and you owe me $4, how much money do you owe me?
$19.
And owing's not good. So do you see how we got that?
Yeah, thank you.
Yep. All right. So turn the page. And I want you to do 1 through 6. While you're doing 1 through 6, I am going to write up an extra credit problem on my board in my classroom. And then after we go over all the problems on this page, I'm going to let you guys do the extra credit problem. And then we'll go from there. All right, let's go over a couple of these. So it says evaluate the expression given the value of x, meaning in each of these equations, these numbers at the end are what we're going to be plugging in. So for this one, number 1, it is 2 times 9 minus 6. 2 times 9 is 18, minus 6 would be 12. Jordan, what did you get for number 2? Angela, what did you get for number 2?
20.
20, very good. So I got -7 plus 9 times 3. Well, 9 times 3 is 27. And then we have the -7 plus 27 is 20. Perfect. Leah, what did you get for number 3? All right, Delaney, what did you get for number 3?
73.
All right, what about Jack?
I got 73 for number 3.
That's exactly what I got. 12 times 5 plus 13. 12 times 5 is 60 plus 13 is 73. What about Sophia Kender? What did you get for number 4?
-16.
That's exactly what I got. So we have -4 minus 12. It's -16. All right, 3 problems left. Number 5. Emma, what did you get?
Can you hear me?
Yeah, I can.
Okay. For number 5, I got 83.
That's exactly what I got. So we have 13 minus 7 times -10. 13. Negative times a negative is a positive. So 13 plus 70 is 83. And the last one. Anybody want to do the last one for me?
Can I do it?
Yeah.
So I got 5 because, do you want me to explain it? Or because a negative times a negative is a positive and you're multiplying -2 by itself, and then 4 plus 1 is 5.
Perfect. All right. Number 8. Why, or number 7. Why did I say stop here and let's do this one together? Because this is what your like things are going to look like moving forward. You're going to have a table of values, and I want to know what it equals when I give you a certain value for x. So what do we do here? All right, I'm going to show my work below. Okay, so for the first one with -8, I'm going to do 1/2 of -8 plus 4. Half of -8 is -4 plus 4 is 0. So that goes there, my first value. Here with 0, I want to do half of 0 plus 4. Well, 0 plus 4 is 4. Now I have 3. Half of 3 is 1.5. So I'm going to write it as decimal because I find it easier here. Plus 4 is 5.5. Number for 6, half of 6 is 3. Plus 4 is 7. And that's how you do it. Any questions? All right.